Hello my friends, I'm back with a follow-up to one of my previous videos. The site chosen was the same busy intersection in the city where I live, near my home. This video was recorded from the opposite side of the previous one. The weather that day was sunny, with significant shadows present on the road. Those shadows can often confuse object detection and classification process, so I use them as a good real-life test environment. The focus of this video is on the pedestrians. On the right side of the screen you can see the video I recorded on the site. With my phone, it is played in the top right corner. Below are the screen recordings from the two browsers showing the counts as they are detected and reported from the Raspberry Pi in real time. That way you can easily follow events as they are presented in the two browsers and compare them to the real situation shown in the video above. First I will show you how the lines are configured. The background is taken from the actual video played. It is important as the lines are drawn exactly over it. The background image is in its original size, no resizing is performed. If you want to see, for example, any of the lines, just double click on any of its ending points. For example, this is line pad. And on the line pad you see that I only want to count pedestrians, so all other classes are put to ignored classes. That means that I will count only pedestrians that are crossing over that line. For example, the line left, you see that I just ignore pedestrians, so only pedestrians are not counted, and any other class of object that crosses that line is ignored. The same, exactly same is for other two lines. You can use the dialogues to update any line manually by entering the values, but also you can use drag and drop. For example, if you want to change the position of any ending point of the line, you just click on it and drag it to the new desired position. All updates are performed automatically. You can also add a new line, for example, just drag drop and add the name on that new line. Click add now, and now we see a bug. It didn't use the starting point as it was, but used the previous starting point. I will solve that bug. It's not very problematic, but you also saw how I deleted that line. You just use like editing and just click use the button delete instead of the button update, and after confirming it is deleted. Use the same procedure, the similar procedure is performed for the defining of the zones. The zones are defined with multiple points, not only two, and you see how it looks. To edit, just double click on any of the zones of any of the points of the desired zone, and then you can see it. You can also add classes to ignore and only count classes of objects that you really want to count. Here are the classes of objects. These are pedestrians. Click on the pedestrian and you see what you can. The threshold probability is the most important part. If you, for example, notice that you don't get detection for that class, because if the probability of the detected object is lower than the threshold probability, it will be ignored, so you just lower it. If you get too many false detection of that class, you just may try to heighten that to increase that probability limit. Those are the counted summary of all this scene. It is 15 minutes of the traffic on that road, so you see how many of any kind of objects was crossing. Now you see how it looks, the zones. We have two zones. For example, the first zone is paddy. You see only counted pedestrians and bike. And for the second zone we have a lot of classes of objects counted for. The most frequent are the cars, so you see that they are dominant ones. And for example, if you see that occupancy for that minute period of time is 0.6, it means that there is a probability of 60% that you will find a car on that inside that zone in a 1 minute period of time. You can also exclude classes as you want, so you can, for example, leave only one class. Then if you exclude that class also, now you see only cars and the truck. You can play with this any way you want, and this is only for information purposes, so you can see how the counting process is work. Now this is the most important part. You can see every count that we have in a grouped in a 5 minutes intervals, you see. And for each line we have 4 lines. You see them as radio buttons above. For example, these counts are shown for the left line, for the right, for the 9, and this is for the pad only pedestrians. 3 in, 1 out, and then you see for the underline. And for example, we go back to the left and see what cars are counted, what trucks are counted. For example, those are trucks. You see exactly time when each of those 3 trucks are counted. If you click, you get the actual image of that truck crossing over the line. The same is true for a bike. You see the bike. That bike is counted exactly crossing that line. This is for vans. This is for motorbike. Over the line left, this is for trailer crossing over that line. And this is a bicycle. This is probably not a bicycle, because for the moment I have a problem with bicycles, motorbikes and pedestrians when they are small, because I trained the network to only count one bicycle when the driver is mounted on the bicycle or pushing the bicycle. And that confuses a lot of detection process, because it sees the pedestrian also, see the person and see the something, and it gets confused, because if from the background it gets something similar to the bike, then the detection process may give you the result of a bike instead of a person. You see that this is very useful feature, because you can actually check how the Raspberry Pi is discerning all the object crossed, and each cross with the time you can show what exactly caused that count. So for example, this is a bus, this is another bus, and this is a third bus in that period. Every bus has its image stored in a database. That database is locally on the Raspberry SD card, so it is limited in size, so there is a process that it is uploading those images and those data, those counts, to the remote location, to the remote server for permanent storage. You see pedestrians, cow crossing over the line that is counting only pedestrians, and you see now the line under. This line is specific because it shows a little object, because of it is the most remote line, and you see that cars are all correctly counted. Motorbike, you see this is the motorbike, this is the truck, and this is its image. This is the bike. Is it the bike? I'm not sure. I think it's only pedestrian. That is still a problem that I'm trying to solve. It needs more images of the bikes when they are small ones, so that the logic can be determined what is the difference that between the pedestrian and the bike with a person on it. So I think it is achievable with more images and examples to train. As I have already said, those data are not real-time data that you see situation developing on the right side of the screen. Those data are taken from the locally stored database on the Raspberry Pi after the video has finished playing and count process is finished. So those data are final data of that count. So and now you see another false detection. This is pedestrian, but it is counted as a motorbike. It has is a black dress, and usually bikers wore black leather suits and pants, and that is probably confusing it. But with a better training set of those little images of motorbikes, and with motorbikes with the bike on and pedestrians, I think that problem is also solvable. This is the settings page. I use it to set. You can upload a new network. So you see, you just have a file locally, train new one. You just upload it, and it gets uploaded to the Raspberry Pi, so you can do it. Video input is the actual file. That file was stored on a USB stick, and I have defined that location. You see media, Tony as the USB movies. That is the location of the Raspberry Pi on the Raspberry Pi disk system, that it draws these files. And also you can see MQTT settings, and the most important part is this archive data arrival interval for minutes. For example, this is 1 day. Each day it will collect all those data, remove it from Raspberry Pi, and send it to the remote location, to the remote web server over a HTTPS request, post request, and then those data will be stored permanently and made available to the customer, so the customer can track each and every count with an image of object that was accounted for. And on the home page there are 3 buttons that are quite useful. Archiving, you can initiate archiving process of local data manually. You can reboot PowerPi, you can power it off also, so it will be shut down and non-rebooted. Also Those two controls to the right are, this one is for starting and this is for stopping the video source you set up previously.